Continuing practice problems from section 12.6, other coordinate systems. This one is number 12, and it asks us to compare the polar graphs of these two functions. So let's go ahead and graph them. First, the one on the left, r equals sine theta. I'm going to need a polar graph, so I'm just going to sketch a rough one here. We're going to basically do just a few points in order to get a sense of it. These are pretty straightforward graphs, so as long as I have a fairly well represented piece of polar graph paper, they should work out pretty well. Okay, there we go. So I'm going to do pi over 2, pi, 3 pi over 2, and 2 pi, and then 45 degrees in between them. So, okay. We're going to start here. Basically, our radius runs along the positive x-axis. So any result for r will go on that axis. And then our angular displacement will be given by theta. So our first point is going to be at theta equals 0. Theta equals 0 is the x-axis. And of course, theta equals 0 gives us an r equals 0. So we're right there initially. That's the point for the positive x-axis. Now we rotate through 45 degrees. This would be pi over 4. The sine of pi over 4 is radical 2 over 2, about 0.7. Next, we'll be up at pi over 2. Pi over 2, the sine of pi over 2 is 1. So we're up here at 1. Next is going to be 3 pi over 4. So 3/4 pi. And we're back at radical 2 over 2, which is positive 0.7. And then finally, we're all the way over here at 180 degrees. We're at pi. And the sine of pi is 0, so we're back to the origin again. Now we can go through the bottom angles, but all it's going to do is map these same points again. You'll notice that at 5 pi over 4, right here, we're at negative radical 2 over 2, so it's simply going to map through the origin on top of this point. At 3 pi over 2, we're going to be right here, and at 3 pi over 2, of course, we're at negative 1. So it's going to map it through the origin up here. This 45 degree vector is going to map it through to here. And when we're back at 2 pi, we're going to be back at 0. So basically it maps a circle that's centered on the y-axis with a radius of 1/2. It actually has a diameter of 1 because it runs from 0 to the far side, which is actually 1. So it basically straddles the first and second quadrant and is generated twice in 2 pi. So we go 2 full laps in running all the way around the polar graph. Okay, well let's compare that one with our cosine theta. So we need another axis, and then our 45 degrees. And for this one, when we're at 0 degrees or 0 radians, the radius is 1. When we move up to 45 degrees, pi over 4, we're down at 0.7. When we're at 90 degrees, pi over 2, we're at 0. The minute we move across to be at 3 pi over 4, we're now at negative values, so we're at radical 2 over 2, but it's negative. And then finally at pi, we're at negative 1. So we're back here where we were at 0. Once again, I can move through the second half, but all that's going to do is remap these points again. So just like with this circle straddles the first and the fourth quadrant. It's got a diameter of 1, so a radius of 1/2. And in the case of this particular circle, it's also generated twice over the span of theta being 0 to 2 pi. So these are both similar. They both form circles that are tangent to the origin, but their orientation is different. The sine forms a vertically oriented circle, and the cosine forms a horizontally oriented circle.